Hi everyone, my name is Arndt Gauer. I'm the customer success specialist at HEO Robotics. At HEO Robotics, we try to make space transparent. HEO Robotics was founded by Will Crow and Hiranya Jayakodi, two graduates from the University of New South Wales. They combined their skills of astrodynamics and mechatronics. We're an Australian company. Our head office is just around the corner. We're also having already a subsidiary in the UK. Our customers are based in Australia, in the UK, and in the US. We have also very recently, actually in the last 2 or 3 days, recruited our first employee in the US. We are currently 18 people within HEO Robotics, and it may be worthwhile to point out that more than 10 of these have started within the last 6 months. So we're growing pretty quickly. We have received funding from high-profile investors, including the founder, or one of the founders of YouTube, Sir David Harding in Intel, and we also went through Y Combinator, possibly one of the best accelerator programs globally. The problems sets that we are looking at are various. We identified, as of today, there are 297 tracked but unknown objects in space. 25% of geosatellites, which are the large, expensive satellites, are failing before their scheduled end of life. We have found, apart from unknown objects, we also noticed that there are objects actually mistagged. So we found 2 mistagged objects in space, and we have identified them and provided further information to those. Another problem set is that we noticed as well that many satellite operators have on average, 3 subsystems that are not used or hardly used at all. And this is adding complexity to the satellites that potentially do not have to be there. Our solution to this, or our solution to many of these problem sets, is to visually inspect the satellites. So on this picture here, you will see an actual image of the satellite. The anomaly of this satellite is that the solar panel is not fully deployed. The operator experienced power issues, couldn't identify where the power issues were coming from via telemetry. So we took this image, separated the individual parts of the satellite. We can see in the red part that the solar panel is fully deployed. The purple part shows that the solar panel is only partially deployed. So how does this help the operator? They can oscillate the satellite and help to deploy the solar panel, or also taking time that they would have spent identifying this anomaly with telemetry. We could do it quicker than they would have done it with telemetry. So our visually inspection is a complement to onboard sensor. It works as well if there's no power when the satellite is not booted up. It allows satellite operators to reduce the complexity of their satellites. In many cases, our visual inspection can provide quicker results than the telemetry, and it provides also information for the end of life or conjunctions if the satellite has to be refueled or anything else. So there's additional information that we can provide. How do we provide this information to our customers? We have a platform that is called HEO Inspect. So it's a software as a service. It's a product that's already available, but it's going through some improvements and upgrades. So within in 2 weeks' time, exactly in 2 weeks, we will have a product launch just around the corner. So anyone interested, please feel free to talk to me later. I'm happy to extend invites to this event. Here, an example of an object that we have identified that was previously unknown. We did this as part of an exercise event, which is called SACTI, which is organized by the US Space Force with commercial operators. Originally, us and other commercial operators that were working on this assumed this was part of a rocket. after further investigating, we found actually that this is a payload fairing, and this is important then for future conjunction analysis or even for deorbiting. One of my speakers mentioned deorbiting as well as an issue, so our inspection service is definitely helping for deorbiting as well, or for conjunction exercises. How do we actually monitor satellites? We do this via flyby inspection. So at the moment we're using Earth observation satellites that we are turning around during downtime and taking images of space objects that are flying past the satellite when we're taking the image. Currently we have 33 sensors in space. We can at the moment take images of objects of approximately up to 700 K, possibly a little bit less. We're increasing this number of sensors to 50 plus. We're very well on track to reach this number, possibly by far exceeding it by the end of next year. That will give us coverage in all LEO, and we will also have our first camera within HEO by next year. Our goal for 2027 is 2,500 sensors, including Earth observation satellites and also sensors that we have developed ourselves. So we have developed our own camera. This is a render, but on the right-hand side you will see the actual camera that is with one of our providers at the moment in the US and is being incorporated into the spacecraft, which will be launching in early 2023. Here a little bit, going back in time a little bit, the HEO Robotics was originally founded by Will and Hiranya to look actually at asteroids. Then they were a little bit ahead of their time. Asteroid mining was a big thing 6 years ago, but didn't really take off. So they saw that the technology can be applied to satellites. But we're looking in a few years again to go back to also imaging asteroids. Prospecting them, and we have a mission that we want to participate in 2029. And if you're interested to talk to us as well, we're looking also for operators of satellites who can host our payload, so can host our camera. So that's something that we are happy to talk to about satellite operators. Or any other questions that you have. If you would like to attend our product launch, I will be here after this presentation.